So we got some PPS CF and GF, and this is an awesome material with some amazing chemical properties that can withstand some crazy chemicals and some very good strength characteristics. And I have a project that I thought would be perfect use case for this material, so that's what I'm gonna dive in and share with you today. I needed a headset holder for my helicopter. So currently, I take it off and I just hang it from my rotor brake. It's definitely not the best solution, and I was looking for something more permanent. When I'm flying with others, usually they'll get out of the helicopter and they'll just lay the headset down in the seat, or they'll put it on the floor. I was looking for something a little better to keep them up and out of the way. So my buddy solved this by buying a headset mount off of Amazon. It was a simple plastic mount. It was actually used for like gaming, video editors. It just double-sided sticky tape to the bottom of your desk. Take your headset off and hang it from there. So he took that, drilled 2 holes up in the top, and then was able to get to the back of it, took that assembly off, and then put the nuts on the back. And it was a nice, secure, permanent solution. He already took all of this off, went in, put lock nuts on the backside, drilled holes. But I didn't want to have to disassemble that HVAC system, and I didn't want to have to drill into it and put nuts on the back. I was looking for something a little easier, so I started looking up there and I found 2 nuts that were already permanently installed there that I could use. And it turns out it was in a really good location right in the center. So I said, okay, I'm gonna use that location. I measured it with calipers, it was 72 millimeters. Once I had that measurement, I knew where the bolt holes needed to go. So we came back to the shop and got to work in CAD. So we started designing the part. I put a nice flat surface on it so that we could lay the part flat on the build plate. Didn't have to use any support material. It was a really relatively easy design and would serve our purpose. So once we got it designed, we're ready to get it and go into the printer. Now I'm gonna be using the 22 IDEX for this part, and we didn't have a profile for this PPS material. So I thought this would be a great use case and a great time to go ahead and develop and get that baseline profile tuned. That way we can share with all of our customers that are using our machines so that when they want to print this material, they have that profile ready to go. So when doing that, I want to start with the 3 main tests. I want to tune in the temperature, I want to tune in the pressure advance, and I want to tune in the flow rate. So we dove into the temperature. So something I found interesting with this CF material was the manufacturer recommended about 315 to 350 maximum on the print head. And so that's what I set the temp tower to. But what I found is in testing, there was hardly any layer adhesion at all. That was due to each layer laying on top of each other. It wasn't hot enough and it wasn't welding together. So we had to bump those temperatures up. I then went from 350 to about 410. And sure enough, around 380 degrees, 360, 370 was still breakable, but about 380, 390, it was getting really hard, and 400, 410, I couldn't break it. And so that showed me that even though the manufacturer recommends a certain spec, you want to do this tuning on your machine and your environment using the nozzles. Like if you're using a hardened steel nozzle, it's probably going to be 5 to 10 degrees hotter than what they recommend. But on this one, it was quite a bit hotter. We had to go up to 390 to really get that good layer adhesion. So I went ahead and set this base profile at 390. A good balance between awesome layer adhesion, good strength, and still aesthetically looks nice. So once we got the temperature tower done, we went ahead and dove into the pressure advance. To get some nice seams, we can check the over extrusion and under extrusion. So you'll see how I did the pressure advance test and got that dialed in. Then I went ahead and finished it off with the flow rate test. By printing all these samples and changing the flow rates, you're able to look at it, especially under a microscope, and see your line and your line widths when they start to come together. A lot of times, just at the base settings, you'll see gaps and it's not getting a good adhesion, you're not getting good strength in that part. So that's a good test to really dial in your flow rate and get those lines really sticking together, creating that strength that you want and need. So once these 3 were done, I was able to get that nice profile tuned and ready. So we went, took that part, sliced it up, got in the slicer, and went ahead and threw it onto the printer. That PPS CF part came out beautiful. I'll tell you, it looks great. It sounds awesome. Sounds like a freaking metal part. Functional, strong, I couldn't break it. So once I was done with that, I went ahead and then started to tune in the GF material. Now the GF material was quite a bit different. It didn't need that higher temperature of around the 400. This one got good layer adhesion at about 350. I will tell you though, this material wanted to warp and peel up from the bed a lot more than the CF material did. I actually made a mistake. I was in a rush. It was end of day. I wanted to start this print. That way I could come back and it'd be ready the next morning. So I just started without putting the nanopolymer bed adhesive on. I came back the next morning and it had curled up a little bit. Part still looked nice and beautiful, but you could definitely see a little warping on the bottom. If I would have just taken my time and put the nano on, I probably wouldn't have had that issue. And so that's what I did. Took the build plate out, cleaned it off, applied the nano, ran another print, and of course it stuck and came out beautiful. I'll tell you, these materials, they are gonna want to warp and peel from the bed, so make sure you check out the nanopolymer bed adhesive. You'll notice on these parts, I don't use a brim. I don't use a brim on any of my parts. I never liked having to peel that off and get the little jagged edges. That's why this nanopolymer was invented. It works with pretty much any material and any build plate. It'll save you a lot of hairs and take a lot of stress out from failed prints. So make sure you check that out. And if you're using the materials, you definitely wanna get yourself some and make your life much easier. Once I had the parts printed, headed off to the airport, and I got the part mounted up, and it worked perfect. Nice and strong, I could pull on it, wasn't gonna break. So one last test I wanted to do is see if I had extra headsets hanging from there, as I'm flying around, yanking and banking, are they gonna stay in place or are they gonna fall off? And so that's what I did. Went around, cruised around the ocean, getting around the cliffs, doing some nice flying, and it worked perfectly. So it's a nice, solid, permanent solution and a great use case for this material. Once I was done, I took the GF one, which is in that nice gray color, went really good with my buddy's helicopter. So I went and gave him one, and I printed an extra one for my other buddy, so he has one for his helicopter if he wants to use it there too. This has been a fun project and a great use case for this material. If you have projects yourself that you think could benefit from some of these high performance materials, high temperature, if you need chemical resistance, if you need to put oils and abrasives in it, reach out to us. If you got a good use case, there's a good chance that we'll be able to print your part for you and help you make a video with it. If you're looking for a machine that can handle any materials and it's gonna print it with the strength that's needed to put it in a permanent use, then take a look at the 22 IDEX. If you need a machine or you're interested in materials or you have projects and you don't know what material to get or what machine to get, reach out to us. We got an entire team, and if it's something that we don't have, we can hopefully point you in the right direction to solve your problems. Until then, have a positive day, and we'll see you on the next video.
Yeah, we'll go, man. Baby girl, we'll go, then. They're about to see it shine, 'cause we'll go, then.